Hello, my name is Kathleen O'Hare, and I'll be doing my project on gas hydrates. So what are gas hydrates, and where can we find them? Gas hydrates are when water molecules form cage-like structures around smaller molecules, with typical gas molecules including ethane, propane, CO2, and methane, with methane being by far the most common because of its smaller size. Gas hydrates are also formed under lower temperature conditions, below 25 degrees C, and at higher pressures, usually above 1.5 megapascals. Methane hydrates have been most commonly found in the permafrost regions and in deep ocean sediments, with about 99% coming from the deep ocean sediments. Known locations of gas hydrates include the Gulf of Mexico and the South China Seas, with many other locations around the world. There are three main types of recovery methods for hydrates, which include thermal stimulation, depressurization, and chemical injection. I'll talk briefly about these processes. So the first process is thermal stimulation. The concept is simple. It's when heat is applied, usually through hot water or a brine solution, to the seeds containing the hydrates till they become unstable and decompose. The gas trapped inside can then be recovered by nearby wellbores. Thermal stimulation can be very inefficient due to the fact that hydrates are not typically found in bulk and usually located around very insulating materials. The second method is depressurization. The concept is to lower the pressure around the hydrates till they become unstable and release the gas. This method has been found to work better when coupled with thermal stimulation due to that the decomposition of hydrates is an endothermic process. The last method is chemical injection. This method is relatively new and understudied as compared to the two others. The concept is to shift the equilibrium curve from this green line over to the red line so that the atmospheric conditions that the hydrates are already in will make it unstable and then decompose on itself. The next thing I'd like to talk about is the energy potential that gas hydrates have to offer. So gas hydrates pose a massive energy potential in the coming years. There is an estimated 160,000 trillion cubic feet of methane hydrates as compared to its conventional natural gas counterparts, which is only at 15,000 trillion cubic feet. This large reserve could supply the US's and the world's energy demand for the years to come. And gas hydrates in deep ocean sediments are estimated to hold one of the largest organic carbons on Earth. The use of gas hydrates isn't expected to grow much in the United States because there is an abundance of natural gas in these shale reserves, and other countries around the world are still very reliant on conventional fossil fuels because the developed technology makes it more economically feasible. But this has a large potential to grow in places like Japan, which is one of the world's largest natural gas importers already, and the large number of hydrate reserves located off their coastlines could cause them energy independence. The commercial use of hydrates isn't expected to really take off until 2030, and even then, this is only going to be a bridge solution. The last thing that I'd like to talk about is the environmental impacts that gas hydrates could have. So gas hydrates offer a massive amount of energy potential that can act as a bridge solution from coals and other high pollutants to renewables and non-polluting resources. And this also may cause some countries to reach their CO2 reduction goals by 2050. But it's important to remember that this is still a non-renewable fossil fuel that stores a massive amount of methane, which is a greenhouse gas 20 times more powerful than CO2. Hydrates are part of an unstable feedback loop also. With the methane being released naturally into the atmosphere, it causes global warming, and that global warming puts those permafrost regions and the deep ocean sediments at risk when the atmospheric and ocean temperatures are rising. A study was shown that it only took 1 degree Celsius for all the reserves off the coastline of California to completely decompose. There's also fear that the extraction of some of the gas hydrates could cause the whole reserve to become unstable. It would cause an unstoppable chain reaction that would cause all the hydrates in the regions to decompose, which could lead to earthquakes or tsunamis. These are my sources, and thank you.